Hello everybody! In this video we are going to build an energy-efficient portable news reader device based on NodeMCU using e-paper display. Sure, you can read news on your phone, that's true, but modern news apps with their algorithms can easily distract you for a very long time. The device we are about to build will help you get important news without being distracted from work or real life. You're watching Logic Gate Labs. Let's get started. The main element for displaying news will be this black and white 2.13-inch display from VAct Studio. The display costs about $14, though if you look around you can find it for as low as $8. The reason I chose this display over an OLED or LCD is the power consumption. This type of display only draws power when it's updating, and even when it's not connected to power, it retains the last data that was shown on it. And for news, we don't need to refresh the display every frame, as we'll only be showing text and displaying a new story only every n seconds. Let's set the default value to 30 seconds. Although we'll only be outputting text, the capabilities of this display are much greater than simple text output. It can display simple small-sized images, any fonts, 2D primitives, various fill patterns, and even 3D primitives. You can even play games on it. For example, chess or Tetris. Of course, you'll either write those yourself or find projects on GitHub. At some point on this channel we can build a full portable console around a display like this. The core or the brain of this device is the NodeMCU, a dev board based on the ESP8266. It runs at 80 MHz, has built-in Wi-Fi, 4 MB of flash memory, about 50 KB of RAM, 11 usable GPIO pins, and costs just $5. That's a very low price for such solid specs, and the Wi-Fi module is exactly what we need here. To see how NodeMCU compares to popular Arduino boards, let's put them head to head in some tests. We'll compare it to an Arduino Leonardo. Leonardo runs at 16 MHz, has 32 KB of flash memory, 2.5 KB of RAM, and up to 20 usable pins. The original costs $36, while a clone is around $8. A direct which one is better comparison isn't exactly fair for our project. They are very different boards. My goal is simply to show what NodeMCU can do by roughly contrasting it with one of the most popular boards in the world, so we have a feel for its capabilities. We'll run a few tests on both NodeMCU and Arduino Leonardo and show the results on a small OLED. The tests include integer math, floating point math, sorting speed, matrix math, CRC32 test, memory operations, pin toggle speed. As you can see, NodeMCU has much better results than the Arduino Leonardo. In some tests, NodeMCU is 10 or even 30 times faster. Beyond that, you can run games on NodeMCU, like Chrome Dino or even a Doom clone. We'll read the new service settings, Wi-Fi data and refresh interval from a tiny microSD card module that costs about $0.50. And this is where we get to how the whole thing is actually going to work. We know the NodeMCU can connect to the internet. We know the display can render text. We need a service that returns news in the agency name, headline or description format. Such services exist. One example is newsapi.org. There are few similar services, but this one is the most popular. You can request news for a specific country and choose how much text to show on the screen. The site returns JSON with fields you'll parse, which means extract the data you need from the JSON. and will render those values on the display. You might ask, what does the microSD card module that we started with have to do with this? And I'll answer. It lets us create and easily change the input settings we send to the NodeMCU. On screen you can see the JSON we'll store on the card. Networks to try lists Wi-Fi networks and passwords. If the first fails, we try the second. If that fails, we look back and try again. Services field tells the device which new service to call, and update cooldown seconds allows you to set the query frequency to service. A service may return not just one headline, but say 10-20 items, which we can rotate locally even if the internet drops. UI controls presentation. Right now, we can set the background and the rotation frequency for the headlines retrieved in a single request. We'll use 30 seconds. Runtime lets us, for example, enable extra output while developing. All of this lives on the microSD card and is read at boot. Now imagine your Wi-Fi password changes, or you want headlines from another country, or 30 seconds feels too fast. Without this, you have to find the project, edit the code, recompile, refresh, and hope nothing breaks. With the microSD and runtime configuration, you just change the file. No refreshing, no complicated steps, no fear of losing the project. We'll power the system with a small 800 mAh LiPo cell for $6. Power will come into the NodeMCU and then feed the other components, but the NodeMCU accepts 3.3 or 5 volts as input, so we need to step down or step up the voltage, because if we don't, the NodeMCU either won't start or it will burn out. For this build, we'll use an MT3608 boost converter. It takes 3.7 to 4.2 volts as input and output a stable 5 volts. The converter itself costs about $50. To charge the battery and even power the device while charging, we'll use a TP4056 charge controller for $50. All of this will be held together on an acrylic sheet, also called plexiglass. But it's actually a plastic that looks very similar to glass. We'll cut it to shape for this project and drill the mounting holes. We'll assemble everything using PCB standoffs and screws. And the result should look something like this. Before assembly, we'll do a quick layout to see how the parts might fit. I'll use Unreal Engine 5. Not because it's the right tool for this, but because I'm comfortable in it from my experience in game dev. Let's try to put it all together. We remove the film and immediately see that the edges are not very even. That's easy to fix with sandpaper. Clamp the panel in the bench vise, protecting it with foam polyethylene so you don't damage it. We sand the panel and we get this result. We'll also round the corners so the device don't scratch your hands. And here's our panel. We'll mount the standoffs with screws. At first glance it looks fine, pretty sturdy even. But over time, vibration can loosen them and the whole system becomes unreliable. To prevent that, we'll use blue thread locker. Add a drop inside the standoff and screw it in tightly. And we get the following result. Now the standoffs will only unscrew if brute force is applied, for example with pliers. In a similar way, we add smaller standoffs that will hold the battery. The battery will sit between them. This arrangement keeps it from accidentally falling out. The boost converter will sit above the battery, leaving a small gap between them. There is one problem. These converter pins, while not touching the battery now, can still pose a risk. Late in the LiPo's life, say in around 2 years, at our modest load, the cell can swell. Those pins could then reach the battery, puncture it, and potentially cause a fire. To prevent this, we must make some modifications to the converter. First, we clip off these pins using side cutters. Then sand them down so almost nothing remains. Finally, cover it with a special insulating cardboard, exactly for such cases. The power subsystem, converter, charger and battery mounts like this. The main parts, the microSD slot and the NodeMCU, once soldered, will look like this. Just in case, I am adding Kapton tape between the NodeMCU and the display. Not required, just my personal paranoia. We secured the screen with screws. Do the last solder joint. Connect WIN and the GND to the converter. Close it up with the front panel and tighten the nuts. And here's the device we built. Let's power it up. You'll see a lot of debug logs on screen. We can easily disable those via the JSON on the microSD. But for this video we'll keep them to confirm a stable boot process. Stage 1. Initialize the microSD and Wi-Fi. Verify both are working properly. Stage 2. Read the JSON from the microSD card. Stage 3. Find a Wi-Fi network we can join, then connect. Stage 4. Request headlines from the news service. Request is successful, response is successful. Stage 5. Parse the JSON from the news service. Looks like we got 5 articles to display. Stage 6. Renders the news. The Wall Street Journal says beef prices at a record highs. Quite an interesting first story. So, that's our little gadget. Of course, it's not perfect. What could we improve? If you plan to show each headline every 10 minutes, for example, instead of current 30 seconds, it would make more sense to switch from delay to ultra low power deep sleep mode. If the internet drops and the device powers off, it would be great to catch the last downloaded headlines to the microSD. Along with this, we could display the date of the news. We could display longer descriptions and add scrolling. This toggle switch doesn't look very presentable. We could hide it or mount it more cleanly to the case. Thanks so much for watching. It means a lot to me. Share your thoughts about the device in the comments and subscribe if you enjoyed the video and want to see more builds like this. See you next time and take care.